IIT-JEE Advanced had sprung up surprises about this equation many times. Look, children, the 10th students, let me see how I will make it interesting for you people. In a rotating frame means I've taken one special case where there's a disk here which is going with a constant angular speed, that is some 12 radians per second, some 30 radians per second, some 100 radians per second, like that. And that there's a body here. This body is also having a motion like this with respect to this disk. Then there'll be forces coming like this. MAK. K I put as reference frame fixed to the ground, which is at rest, which is along with this axis as well. That means somebody is standing in the lab and watching. Real forces means just now Shreya was asking, Shreya Khanna or Shreya Dhama. Look, normal contact force, friction, weight of an object, force of buoyancy, K Q1 Q2 by R square, some forces which I'm going to discuss in future. That kind of forces will be there here. In this case, mg and n, and probably friction. These are the real forces, children. Plus Coriolis force. Coriolis force. This word people have heard in geography in their 8th, 9th classes to explain how the wind moves and forms what you call this cyclones and all that. So that's the Coriolis force. This is the centrifugal force. So this equation is the most generalized equation. And look, if this body has no velocity here with respect to this v dash is velocity with respect to the rotating frame. If this is not there, I'll get real forces and centrifugal force. Even if this omega is not there, I'll get only real forces. This is real forces, Coriolis force, centrifugal force. This is the net force in a rotating frame of reference here. This is the most important relationship I've given here. I'll wait for a while. But I'll give you a nice example as well for this. Say you are a dancer, ballet dancer, who are just dancing on this rotating platform, and you are walking like this, for example, on this one. You'll feel, if you're walking, if you just draw one line and walk along this, you know practically that you need to put your feet somewhat like this, slanting to the line, because you'll be slipping otherwise this way. If the disk is rotating that way, you'll be slipping backwards. If you're not slipping, you've developed a friction that way. And you also developed a friction this way. If this friction was not there, you will simply slip like this as the disk moves like this. Think of walking on a rotating disk. You'll be somewhat pushed sideways. That pushed sideways force is called Coriolis force. Actually, I told you I start from there and come to this mathematics. Today, I start with the mathematics. That's what I mean, the top-down approach. But finally, after finishing first year or even before finishing first year, you should think that physics is only in terms of nice formulas like this, generalized formulas. They become many other formulas if you go on removing the cases. So there's a sideways deflecting force called Coriolis force, and there is a centrifugal force. So most important equation for the Newton's laws of motion is this. So I told you Newton physics will apply, and we talk in terms of the reference frames. Two formulas I've given you. One is for the linear motion. The second is for the rotatory motion. After that, there's nothing. You bring one problem, I'll show you that it is from there. Do you follow this? Okay, I think I need to go a little ahead because, yes, now the Newton's second law. The most important law, the most important formula, if you want to call it. I've given it in the most general form. Yes, sir. We studied Coriolis force in 9th class. Yes, 9th geography in the weather chapter. Yes, to understand the motion of atmospheric air. That's correct. But now it is all like that, mathematical. You'll come back to that once again. Okay. As I told you, make notes of only the main formulas which I'm mentioning here. I repeat my statement. At the end of the first year, you'll say, Arey, why did we spend so much time After all that, only this much only we have, no, you will say. That's the beauty of physics. It looks so small. It looks so small. And very, very successful people, successful speakers, especially the Swamijis or the politicians or the statesmen, they sit like that and speak hours for hours. Fidel Castro is known for speaking for hours. How do they speak for hours like that, you tell me? They have an engine, small engine, where there are basics there. They don't go out of those basics. They go on elaborating that. The trick of speaking for hours is that, believe me. You can go on doing it forever and people don't understand how are they speaking like that. Because they always have that engine, I say. The main engine where 1, 2, 3, 4, 5, 6 ideas are there. And they know how to start from the ideas, go here, go there, and come back to the idea. This will be a great what you call quality if you would like to develop, if you want to become a powerful speaker somewhere later. Okay, now mass will change. Look, I've given the example here. Mass varying systems. Mass varying system. There's a rocket, children. There are gases inside. If I take this rocket and inside thing as one system, as the gases are going out, mass of the whole system is changing, children, right? Isn't it so? Tell me, children. Suresh, yes, tell me. So I'm writing for once again, I want to show that generalization. What is the generalization? I'm writing for a mass varying system first, and then making it for a mass constant system. That's what you mean by going from general to particular. Look at this, Newton's second law in the most general form. F external equals, here in the case of a rocket, what are F external tell you? As it goes up, the air friction, okay, and the force of buoyancy and its weight are the external forces. And dV by mdV by is ma, simply acceleration of the rocket into acceleration of the rocket means that mass at that instant, because the mass is going out. Okay, that mass, instantaneous mass into instantaneous acceleration, plus this fellow is called thrust. The thrust is provided by these outgoing gases. Tanai, sir, if velocity is higher, then there will be slight change in mass. That's something different, children. That's Einstein's idea. That I'll come back later. Look at this case first. I'm telling you, this is one formula. If you understand, you've understood Newton's law, second law properly. Just look at that carefully. I may explain the meaning of dm by dt is the rate at which the mass is coming out. And V relative is, you stand here and watch this mass going out. That velocity is called V relative. The velocity of the outgoing gas with respect to the person in the rocket is what you call V relative. You'll integrate. Don't go ahead of me. Just first get this meaning. Why sir is talking about this equation? That's very important. Slight change in mass, all that will be different, Tanay. That's not the point right now. Can we call pseudo force physical? Yeah, there's a big discussion. I've done a special class on pseudo force. You can watch that. Pseudo force, gravity is kind of a pseudo force. Einstein already proved. But other forces are pseudo forces, not yet, children. Right. Now, Newton's second law in its most general form is this. And if I bring this thing to the left-hand side, I'll get the total external on the remaining rocket. Remaining rocket means every time the rocket keeps going like this mass m. So total force on that will be, say, for example, air friction and force of buoyancy, weight, and then this V relative dm by dt applied by the outgoing gases on this rocket. This is how you understand it, and then do the problems later. I want people to remember that. The derivation of that is actually not very important. When a rocket, see, a Diwali rocket, you all the time fire, right? A Diwali rocket, you fire. So for the Diwali rocket, how to write F equals ma? Every time some mass comes out, for that remaining mass, we apply F equals ma. If you do that, there are what forces? As the rocket goes up, air friction. Since the rocket is in the air, there's an upward buoyant force by the air, and then there's weight of it. But also there is thrust provided by, we call it thrust by habit, by people use that word. So the thrust provided by the outgoing gases on the remaining one. So all put together gives you the acceleration for the mass. And if dm by dt is 0, if mass is not changing, it simply reduces to our main equation Fx equals ma. Or in general, of course, all this can be put into one scheme of things, dp bar by dt. So the most important equation for us is Fx equals dp bar by dt in the whole of JEE physics. That can be understood in many ways, children. All right. Okay. Then, but remember, this F equals ma was written for a particle by Newton. Newton actually gave it for a particle, but people extended it later for system. Now you know that when you write F external equals ma, you're actually writing even for a system of particles, but in that case, F external equals mass of the whole system. There may be many particles, disjointed particles, not like a bat alone, into what we call as ACM, acceleration of center of mass. That means the whole body, for the sake of F equals ma, will be considered as a point mass at the center of mass. And for that, you write the Newton law of motion, this one. So this is Newton's second law extended to many particles, this one. And an example here I have given. It looks as if there is one point here which behaves as if the total external force called mg is acting only on it, because of which that center of mass goes in parabolic path, whereas the other particles of the bat keep moving around the center of mass like this. So Fx, I've given you the most general equation for Newton's second law, but I told you I've applied it for a system of particles. These are what you mean by the basics, children. Actually, if anybody is getting a doubt as to what basics mean, they are the basics. Poll I couldn't start because this is too heavy a topic. Now, yes, if F equals ma is the main equation, what is the technique for applying this F equals ma for a system of particles? FBD diagram approach to solve problems, or the isolation diagram approach to solve problems. Look, there's a lady here having that bag and walking. So I don't want to study the lady here. I want to study the bag. That's what you mean by free body diagram approach. Think that this bag is separate from the lady. Don't forget that the lady is the one who is holding the bag. Don't forget it. But at the same time, just pick it out of the whole system there and write down the force on that. That's what you mean by free body diagram approach. Can somebody guess what are the forces on this bag as the lady is walking? What could be the forces on the back? One is the weight of the bag, right? The other is the force of buoyancy on the bag. As she walks, this way velocity is there. There's a friction on the bag. Yes. And there is tension in the handle. Don't say she's applying a force. She's applying a force in the form of tension. So there's a tension, net tension like this of the two straps. Tension, force of buoyancy, force of air friction, weight, are all the reactions of other bodies on this block. This bag's thing, there's a tension developed here, the net tension is somewhat like that. So there's a tension applied by the lady here on the bag, and friction and all. These are the forces, and net force of all the vector sum we should do, because they're all vectors. So we should write B bar plus F bar plus T bar plus air friction is over tension. All this is equal to, you write ma. That's what Newton's second law is about. Vector sum, of course, the techniques will be developed to tell how to find the net force. Even 11 students might have done by this time. The resolution of vectors, cosine rule, all that. Okay, right, children. Yes, Newton's second law I've talked. Remember, you need to really catch the meaning of what I'm saying. Sir, buoyancy force is only in fluids. Yes, fluids, air is a fluid, right? When you are walking through air is a fluid that will apply a buoyant force on you, right? Okay, now, yes, a gas is also a fluid. Yes, okay. Shivansh Pandey. Can we call, okay, what is this? Can we feel pseudo force physically? We can. Oh, sorry. Leave this. Legend. This question has only image attached. Legend, you are legend. So where is that I can discuss your questions? Is mathematics the language of study physics? Definitely. Isn't it, Manoj? Sir, what about weightage of ray optics in JEE? Weightages, that can be done separately, but weightage will be around 4 to 6 marks you get. That's an easy topic actually. You don't have Newton's laws and all that there. Okay. Bairam Palli Shailaja. Is this session useful for incoming junior? Why not? For them, actually, it gives a full picture, framework for the whole 2 years, right? That's why I was asking them to write. I was telling you also, no, at the end of the session, I mean, not session, at the end of 1 year, you'll know, okay, all these things are taught in only a few hours, they think. They'll be definitely useful. And they can listen to it without any pressure. Okay. Now, yes, this is the free body diagram approach. So Newton's law in general form, and then Newton's law when dm by dt is made equal to 0, and the most general form dp bar by dt, and then how to apply it for problems. That is for FBD approach. But meanwhile, people are talking what are real forces and all that. Stay with me. There's some more time it will take. Actually, I think I was too ambitious, but all right, we'll try. Because we're looking at the chat and also discussing it in more details, keeping 11 students in mind, we are falling behind. All right, no problem. What are the forces? We give names to many forces in nature, starting from muscular force to your force, my force, hitting force, tension, friction. All these words can be classified under one single word called statistical forces. What? Statistical forces. But no more we deal with statistical forces. People already found that there are only 4 kinds of interaction in nature, and people got Nobel Prizes for that, believe me. Okay, so all the forces in nature will be classified under gravitation, electromagnetic, weak interaction, strong interaction. Strong interaction is the one which binds the nucleons, and that is neutrons and protons together. Weak force explains few decays, for example, beta decay. These are all IIT-JEE syllabus only, children. Electromagnetic force is all that is very, very common. Every day we are dealing with electromagnetic forces. If I ask you a multiple choice question, which I don't have time now, which is the most common force of all these A, B, C, Ds? This is A, this is B, this is C, this is a D. I'll start the poll. I've already given the answer. Which is the most common force of all 4 forces? Just check that in quick way. Let me see. Oh, that's not good. Most common force in nature, everyday life, let me say. Okay, where is that thing going? Oh, okay. Not a bad thing. So some people are putting for gravitation. Not really. Let me see. Share with the learners. 1, Sankalp, Aryansh, Raj, Prithvi, Srija, Yadnya. Yes, the most common force is electromagnetic force in our daily life. Gravitational force is very important. We are stuck to the earth because of gravitation, but gravitation becomes significant only between you and earth. Between me and you, gravitation force is almost insignificant, children. But when you shake hands, When I'm talking like this, my cheeks are moving, my skin is extended, and when I close my eyes, I'm doing something. When I'm clapping like this, I'm doing something. Every act of my physical movement, there are electromagnetic forces, children. So the most common force in daily life is what? Electromagnetic force. Electromagnetic force is what? The reason for this developing of this force is charge, children. Okay, we'll be coming back to that. But it's a general broad classification. There's a broad classification, children. But now we will be dealing with only few forces, children. I'll just go a little, I'll show you what kind of forces we deal with and come back. Weight we deal with, right? And then, oh, this loading will become a problem, I think. Then molecular forces like N and tension we deal with. Tension and weight, tension and string, normal contact force and frictional force. Okay, and then, yes, some meaning for that. And then, okay, friction only. Then Archimedes principle, that is force of buoyancy we deal with. And then electric force, that is Coulomb force. Then force on a moving charge, and then force between two moving charges, force between two parallel wires. That's all and nothing else. These are the forces in IIT-JEE physics. Actually, IIT-JEE physics, I should not say. Those are the forces in 11th and 12th syllabus, but that's all. So only these forces we deal with. Do you follow? I'll come back to explain each of the forces anyway. But I just wanted to show you that this is all the syllabus we have there about forces. Right? Look at this. Each of these things I'll be dealing slowly. And remember, this complete exam-oriented talk I'm doing. In what sense, anytime you get a doubt, where will you run? You'll run to that basic. Either the teacher should tell you this is the basic, or you should remember, Hare, this was my basic which I forgot. So everywhere, whatever I presented is the root, the ultimate. After that, there's nothing else. That's what my assurance to you is. So that's why for 10th finishing students also, who are just starting to do 11th, this is important. People keep asking me, sir, tell me important formulas. I need not to frame any formula. Formulas are already there, children. Okay, don't worry. We're a little behind, but anyway, we'll come back tomorrow. Yes, we'll discuss these forces. It's all maths once again. Yes. See, we said gravitational force, no? That is the one we are discussing as weight in our case, weight of an object. Okay, in a small summary itself, everything is mentioned. Be careful. This is F equals mg is the way we talk, the force with which Earth attracts a mass. And Earth produces an acceleration g. We know everybody, 10th class, 8th class, 6th class, everybody now knows that. So mass of the body into g, the acceleration due to gravity is called the weight, people say. But remember, children, finally, that g will be nothing but gm by r square, where m is mass of the Earth and r is the distance from it. So this g will be called gm by r square. So the weight is nothing but gm1 m2 by r square force. Newton actually has given us this law. Between two masses, there is always an attractive force that is given by gm1 m2 by r square. And this will be written as, for the sake of weight, gm1 by r square, which is g by m1 into m2. For example, if m1 is attracting m2, and if I want to know the weight of m2 in the field of m1, I'll say this is g of m1, that into m2 is force or the mass, weight. So this is the most important relation. That's a general definition people give all the time. Okay, just stay with me for some more time. We'll continue this tomorrow. Don't miss the class, because I told you already, 3 days continuously you listen, you'll actually understand why this kind of a revision is very, very important.